Hello, assalamu alaikum. Welcome to GFC School. This is Mohammad Gyashuddin. Guys, today we'll discuss mechanics of class 19 Edexcel physics. Guys, you can see some MCQ question. Assalamu alaikum. Hello.
Hello.
Hello, assalamu alaikum.
Walaikum salam.
How are you?
Hello. Am I audible?
Yeah. How are you? How are you?
I'm great, sir. Thank you. And what about you?
I'm pretty well. I'm also waiting for you, but there was problem in network. That's why it took time. It took time. Anyway, at the 11th hour, your father has knocked me. That's why now we are connected each other. Anyway, your name, please. What's your name? Can you see me?
Yes, sir.
Can you see me?
Oh, yes, sir. I can. But I think the volume is a bit low, so I think I can hear less.
Low. Sound low.
Yeah. Yeah.
Why? Let me show. Let me check this.
Sure.
Your name, please. What's your name?
Oh, I am the boss talukdar.
Repeat, please.
The boss talukdar.
Dibas Talagdo. So wonderful. So sweet name.
Oh, thank
Okay,
you, sir.
Dibas Talagda. After all, what class do you read now? Do you study now?
So basically, I'm in the ninth grade, and
Those
then I'm also preparing for the IGCSEs.
nine. I see.
IGCSEs.
As he says, okay, nice. And your syllabus very well. Am I right?
Yes, sir. Kind of.
Okay, fine. But now we'll discuss a bit. After all, today I performed my Tarawih Nawaz and
Sure.
just now have come and I'm trying again and again, but network was unstable, so I couldn't connect and I couldn't get confidence.
Oh, I see.
Your father knocked me. That's why I'm happy and I have connected to you. Anyway, Deba Shish. His name Devashish.
Dibas. Also
Debas.
pronounced Dibosh in Bengali.
Debas. Okay, nice. Debas. Actually, whenever we wanna learn physics, we have to look at mechanics at first. And how much do you know about mechanics? Now, I may show you some question, MCQ. And seeing those MCQ, we may try to understand the mechanics of our physics. And so for that, your Edexcel IGCSE syllabus a bit different from Cambridge. Am I right? Do you know?
Yes, sir.
Do you know the difference and how much tough or how much critical your Edexcel and how much tough the Cambridge? Do you know the difference?
Yes, sir. I have quite a few ideas.
But I also that do you know the question pattern of Cambridge and do you know the question pattern of Edexcel?
Yes, sir.
Far difference. And your question pattern and answer pattern descriptive. Am I right?
Yes, sir.
Not directly equation based. And there are 20 to 40 MCQ in Cambridge, but you use 10 to 5 to 10. Am I right?
Yes, sir.
Okay. Now we can test or check us how much do you know about the mechanics.
Sure.
Very simple thing we'll discuss now. You can see the first question, a car travels 100 meters in 5 seconds. This velocity is how much?
Yeah, it's 20 meters per second, option B.
20 meters, that means well. It's very easy. And second on the body, just we wanna recap and we wanna justify how much we know the mechanics. It's a very simple. This is very simple. Question 2, a body changes velocity from 5 meters per to 25 meter in 4 seconds. You know this. It's very simple.
Yeah, this
Very-
one must be 5 meters per second squared, option B.
5 meter per second. 5 meter per second. Very easy, right?
Yes, sir.
And the body starts from rest and acceleration is 2 meter per second for final velocity. You can do this too.
Yeah, this one should also be 10 meters per second.
10. Now, without writing anything, you can say the answer. That's,
Yeah,
pretty good.
easy.
You're very excellent. Your father said you are very talented, and he was actually saying a lot about you greatly. Okay, he praised you from his core of heart. That's why I'm counting you, hearing those comments about you. Anyway,
Oh,
even though I've said or I'm going to describe very simple thing related to mechanics. Anyway, now you've done 3 and now 4. 4 very easy. You can say very simply displacement.
I guess the number 4 should be 75 meters.
75. So what's the equation here?
The equation I've used is S equals EUT plus half AT squared. Then I've substituted the values in.
F equal UT plus half at squared. This.
Yes, sir.
Oh, you know what? Nice. Half at squared. This is very simple. Even though I have given, even though I have been discussing. Anyway, don't think any wrong really. Okay, our body moves such that way Visca and Visca minus for access into the displacement. What is the displacement? Can you solve this?
Yeah, I think I can solve it. I can try some equations for that. So I have an equation that like v squared equals q squared plus 2as, which includes all these squares. Maybe I can use it.
What's the amount? Here, question has asked to find out the displacement. And we know the formula. We can, you know.
Yeah, so I think if I use the formula of the like v squared equals q squared minus plus 2a.
Is this?
Yeah, yes, sir. That's what I'm talking about.
Why is A? You have to find.
I have a, yeah.
A has been given here.
Yeah.
Acceleration 2 meters per second, and putting A, and since V square minus A square has been given, 4.
Yeah.
That's easily you can find out the value of S.
Yeah, it came 10 meters.
10 meters.
Yes, sir.
40 upon 2I. That means 2 oh my gosh, you have done this so easily. Within short time, you have solved.
Oh, thank you, sir. Yeah.
Good, very good. Excellent. Good question. Questions are not as big as this, and I know that. Anyway, force of 10 Newton x on our mass of 2 kg. Acceleration.
Yeah, so it should be 5 meters per second square, option B.
Oh my gosh, very easy. All right, very easy.
Oh, thank you. Yes, sir, it is.
You're down. Pretty well. Momentum of 2 kg object moving at 5 meters per second. Momentum.
So it's 5 times 2, 10 kilograms times meters per second, option B.
Which formula, yeah?
It's P equals mv.
A B. So what is B? What is M? Oh my gosh, it's easy.
Yeah, there is.
You're faster, smarter.
Oh, thank you. Thank you.
Okay, force of 20 Newton, action to now do this. Okay, nice. Now impulse. What is impulse?
I think I kind of cannot remember the formula of impulse, but is it anything like F times S or F over S?
How much? It's a impulse. Impulse means it's a level question. That means A2 physics level question. It's not a O-level based or IGCS based. That's why you are in suspicion. Always on you don't know this formula because it's a A2 level physics related.
Oh.
Okay, that's why you are unable to this. I know because today I solved this problem to my S level physics. That means that student said this positively when I asked him That means, have you understood what I've said? I saw
Yeah,
this question. I saw this.
I studied impulse, but I kind of forgot maybe how.
Yeah, no. It's not actually O level based. It's A level based. Okay, but formula is connected to O level. But
Oh,
during O level, you didn't get this word impulse. During
I see.
S level or A level, you'll get this word impulse. Understand what I've said? And
Yes,
that
sir.
means impulse word you didn't get 9 or plus 10. You'll get this word in AS level. Okay.
Oh, yes,
Yes,
sir.
sir. That's why you are in confusion and you are unable to do this. It's not your problem. It's a class problem. Okay. There's a difference between standard 9, 8 and AS level or A level. Anyway, whatever that means here, your answer is 40. 20
40, okay.
times 20 times 2 because impulse means change of momentum, change of momentum equal force times t, force times and you know the formula. If sorry, take me the pen. If you know this formula is familiar to you, is familiar to you. uh, uh, mb minus mu is familiar to you.
Yes, sir,
This
I know
formula.
that.
Right, from this formula, you got impulse, but you don't know that during O level. Okay.
Oh, I
S
see.
level, you get this word impulse. Impulse means this diagonally multiplied. Force times t means change of momentum. Change of momentum. Okay, let me write by pen. Then I can write so speedily. Anyway, and you know, this formula from Newton's second law. MB minus
Yeah.
MU. We know this formula. We know this formula. And from this formula, this word has come, impulse. That means
Oh, I see.
if we multiply such way, then we'll get the difference between momentum. The change of momentum means the difference of momentum means impulse. Impulse means force time t. Force time t. Okay, this is the impulse. Okay.
Yes, sir, understood, understood.
Now, what a 5 kg? You know this. It's very easy.
Yeah, this one is 50 newtons, option C.
Okay, you know this. Work down one force of 10 Newton moves on an object. You know this. It's also very
Yeah,
simple.
it's 50 joules.
50
Yes,
joules.
FS.
That means if you know
Yeah.
the formula or basic, then you can do this mathematics very easily. And I've given very easy formula based something. Just
Yes, sir, I
since
understand.
3 day our first class, that's why I've not gone into the deep concept. Okay. Anyway, now kinetic energy of a 2 kg object moving at 3 meter. You know this, I guess.
Yeah, this one's 9 joules, option C.
9, and then what's the formula? What's the formula?
It's the kinetic energy, or EK, is equals half mv squared.
Have been squared. Oh
So
my
m is 2
God.
kgs and v square is 3 square 9. Yeah.
Potential energy of a 2 kg object is 5 meter. You know the formula? Do you know the formula?
Yes, the potential energy is equals to mgh.
mgh. mg. Nice.
Yeah, so it's 100 joules.
And power is 100 joule. Work
The
done.
power is 20 watts.
Oh my gosh, you're very smarter and better.
Oh,
And
thank
you
you,
have
sir.
done all pretty well. And so
Oh,
quickly you have done this. You are doing this. Okay. Pressure one force 20 Newton X on a
this one's
nice.
10 pascals.
On you know the formula. That's done. Okay, velocity
Yeah.
doubles kinetic energy becomes
It should become 4 times.
4 times.
Yeah, 4
4
times.
times. Oh, you're so faster. Okay.
Oh.
Now actually also syllabus. Do you know your syllabus? Do you know? Do you know your syllabus?
Yeah, I know it kind of.
Kind of. Okay. This is actually kinetic energy picture, photography, or work done. This is work done. You know this. That's why not necessary to describe this. Change in momentum. This is the change of momentum, and this is momentum formula, force formula, and mechanism based all equations here. Now you actually you syllabus this forces, motion mechanics, distance, displacement, speed, velocity, acceleration, graphs, distance, time, velocity, time, meters. Am I right?
Yes, sir.
Energy, kinetic energy, potential energy, work done, waves, types of wave, transverse wave speed, reflection, refraction. Can you differentiate between reflection and refraction? Can you differentiate
Yes, sir.
reflection
Yes,
and
sir.
reflection? Can you draw the picture on your paper by pen? Then you send me to WhatsApp.
Sure, I can.
Reflection.
Yes. I'll take a minute and then send you right now.
Yeah. Can you use chat or can you use WhatsApp? Just you can send the picture to WhatsApp.
Oh, yes, sir. I have drawn it. I've only drawn a simple diagram, but if you tell me I can draw the complex diagram and add every detail, should I add every detail?
No, not necessarily. Just tell me the difference
Okay.
between reflection.
Okay.
You can say
Okay.
only. You can say
Yeah, I'm sending the picture.
reflection and refraction. Refraction and refraction. Sounded very speed. So yes, okay, got it. Now, please write down your name here. In chat box, you may write down your name.
Yes, sir.
Your name, please.
Oh, my name. Okay.
Your chat box.
Yeah.
Your name and chat box.
Yeah, sending.
You know the chat box?
Yes, sir.
Are you habituated to use each command of Zoom? Are you habituated?
Yes, sir. I am using it for a lot of years.
Okay, nice. In chat box, please write your name.
Yeah, I have sent it.
Nice thing. Now, I guess you've done the picture reflection. It's very
Yeah, I think I'm sending it, but I'm having some network problems on WhatsApp, so it'll take like 20 seconds.
You will send this through chat.
Yeah, I have sent it on WhatsApp.
WhatsApp.
Yeah.
Okay, let me check this. Okay, nice. This is okay, fine. Reflection you have drawn pretty well, but you have not drawn the normal. Why?
Sir. So you said I should only draw the simple diagram, so I only draw the simple. But if you want, I can draw the normals and everything else.
Anyway, you drawn all. Okay, fine. You have drawn diffraction, but you have shown the diffracted ray towards the normal, but you didn't draw the normal anyway. And you have drawn the incident ray and refracted ray, and you didn't mention the medium. Okay, which one? The first medium and second medium. If you draw such way, what I will say? The second medium is rarer or denser. Which one? Second medium.
Yes, sir.
You have drawn the diffracted ray towards the normal. That means was the second medium. First
so
medium,
the second medium is the denser medium.
Denser medium, right? That's why diffracted ray means towards the normal. And when a light passes from denser medium to rarer medium, then you will draw the diffracted ray away from the normal. Am I right?
Yes, sir.
Close to the normal. Anyway, you have done pretty well. But if you draw the normal and mention the medium, I would be happiest. Now I am happier. Okay.
Oh, sorry, sir. I will do better next time.
Okay, nice. And now, could you tell me what's the difference between transverse and longitudinal wave? And can you draw
Okay,
the
so
picture? If you can draw the
yeah.
picture, please draw that and send through such way.
Oh, sure,
You
sure,
have said
sure.
no. That means transverse and you have to mention here, and you have to give the example which are which thing follow transverse and which energy follows longitudinal. You will give example.
Okay.
You give transverse wave and longitudinal wave.
Yeah, so there are many examples of transverse and longitudinal, but the main examples of transverse waves are like electromagnetic waves, then light energy waves, and examples of the longitudinal waves are sound waves.
Sound waves. Okay, nice. 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 You can do this, and you know this well.
Yeah, I'm sending it.
But could you draw longitudinal wave? And
Sure, sure. I'm drawing.
with a sound anywhere, could you see the example of longitudinal wave anywhere? Spring, is it transverse of or longitudinal? Spring. If you just pull and push spring will move. In which way?
Yeah.
Is it not longitudinal or transverse? Spring. If you pull a spring and release it, then it will vibrate.
Okay, so should I explain it as well?
Repeat, please.
Like, should I explain also?
It could explain.
Okay. So
not necessarily. Not necessarily. You know this. Okay. Now, yeah. Okay, you know transverse waves and draw the picture. Okay, draw the.
Yeah, I've shown it.
You know the example, but I don't know whether you can draw or not.
Sure.
So then you understand. Just now you've done the deflection. Then I understood that there is not drawn the normal and there is not mentioned the medium. Anyway, if you draw the transverse and longitudinal, then I understand what's the lacking. So what should you do?
So I think I kind of cannot remember the longitudinal, but I can draw the transverse.
Transverse is easier.
Yeah, but I forgot the longitudinal one.
You've forgotten.
But the only thing I know that the longitudinal one is kind of like a spring.
Yeah. And just now I mentioned, I said spring.
Yeah.
But you didn't say first. You said just sound wave is non-wave.
Yeah, sound wave is an example.
Example.
Yeah, like I've sent it. I think my longitudinal one is not accurate, but I think it's kind of like explanatory. But the transverse one is, I've drawn it as good as I can.
Okay, transverse was PTO, and longitudinal you have done a bit mistake because some wrinkle, some actually spring portion would be very close to, and some portion would be very loose, but you have drawn all are very close to.
Oh, I see. Like contraction and rarefaction.
Okay, draw again. You have done well. You know this, but a bit you have to change.
Okay, I'll try.
Pretty well.
Okay, let me send you another one. Is it accurate enough now? I sent it.
Let me check. Which one?
The second one I've sent.
Second one. Okay, longitudinal. Okay, but you have shown the string state, not actually state. Let me draw this, then you may understand. Or I may show you. I may show you from the internet. If you try to let me show that. let me search that. I may get from the website. String,
Yeah.
waves, animated take in physics.
By drawing daily sketches, you can develop discipline, improve your skills, and foster new ideas. It serves to relieve stress, represent a feeling, or document your life through observation. Our entire inner world fits within the.
Okay, then you keep regardless of PlayStation doesn't start. I've got something with
This is actually shape of spring longitudinal.
Oh.
Just want to see the graphic picture. Now you can see. You can see. Some are very dense and some are not very dense.
Far away.
Not
Yeah.
far away, not close to it. Some are such a you have to do. And let me show another portion. It is not still clear. We have to take another picture. Okay. Okay. I guess you have understood. Simple harmonic motion, string motion.
Sure, I think I have understood the diagram.
Yeah, you understood. I know you've understood. Look, here, now look at this. You can say this portion complete fantastic with this portion.
Oh.
What is the difference? Look, these are very close. These are far. Understand?
Yes, sir.
These are not so close, but this portion is so close. This person is so close. This person is so close, but these are far from each other. These are far from. Whatever, we can make spin both ways. We can make this. If we vibrate such way, string, Roshi. If we try to vibrate from two person, then we will see this also. This will.
Yes, sir.
Such way. And moreover, if we push and pull, then you will see this. That means the spring makes two waves, not only transverse longitudinal wave, but also it makes transverse. You can see this from the picture. This picture you may understand. These two types of waves which are transverse
Yeah.
and longitudinal. But that
Yes.
by spring, you may make both waves. But
Wow.
sound wave is longitudinal. Longitudinal, and do you know the shorter difference between longitudinal waves and transversal? Do you know the shorter difference? Shorter,
Short.
shorter. That means very, 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 very important
Simple.
difference. Important difference.
Oh,
What's that?
I'm not sure.
You're not sure. You're not sure
Yeah.
because very, 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 very deep concept based notion. Okay, very deep
Oh,
concept. Look, here we try to understand. This is a point. This is a particle of medium. It will vibrate. Look, it will vibrate such way. Such way. Okay. Then by this vibration, we'll get this formula, transverse formula. The particle of the medium will vibrate like this way. Such way will vibrate. Okay, particle, but they don't move from one place to another. They don't displace. They will just vibrate with respect to their balance position, with respect to their equilibrium position. They will vibrate, and by this vibration, there will be created a wave, and through that wave, what will be passed? What will go? What will be passed from one place to another place? Through wave. Do you know? Through wave
energy.
energy.
Yeah.
Good. Through this longitudinal wave, sound energy goes from one place. Sound energy propagates from one place to another place. Through longitudinal wave, sound, and through transverse wave, light energy goes from one place to another place. But the particle of medium doesn't move. The particles don't move. Is it clear?
Yes, sir.
Do you understand?
Yes,
Have
sir.
you understood? Particle means the medium particle. They don't displace from one place to another place, but they will vibrate with respect to their mean position. Look, Sasna, I've drawn this picture. I've drawn particle are moving such way, but they don't displace.
Yeah.
Energy will displace, and this is the direction. Which direction? Direction means wave direction. Am I right?
Yeah. Yeah.
And the movement of particle, the angle between the movement of particle and the direction of wave, how much? The angle, how much?
The angle.
Angle between the movement of particle and the direction of wave, how much the amount of angle?
Not sure.
This is the shorter concept. This is the deep concept, and this is the main features of a transversal and longitudinal waves. When you think about transversal, the angle between the vibration of the particle and the direction of the wave is 90 degrees. Is 90.
Oh.
Understand? This is the
Yes.
this is the direction. This is the direction of wave. Okay, and this is the direction of movement of particle. Now, let me take another color. Then you understand. Suppose this is a particle, or this is a part of the string. This string part is vibrating such way. On time go along this direction, another time it goes along this direction. But wave direction this. Okay, so you can count this section. It is 90 degrees.
Yes, sir. I understand.
Direction. This is the shorter feature nature of transverse wave. But longitudinal wave, what is the angle between the vibration of particle of the medium and the direction of the wave?
It should be 0 degrees.
0 degree. Just now you understood the transversal, and so that's why you have assumed the main point of longitudinal waves is 0 degree. Can you explain?
Sure, because the direction where the
Yeah.
particles are moving through are sideways, like left or right, especially right, and also the direction of the wave transfer is
Same.
on the right. Yeah,
Okay,
so the angle is
you got it.
basically on the same direction, 0 degrees.
How have you said this? How?
Because according to the wave diagram of a longitudinal
No,
wave,
just now
okay.
you've understood the wave diagram of transversal. That's why
Yeah.
you taken decision it would be 0 because you can see from this figure this is the direction of wave and particles. Suppose this part is moving sometime along this direction, and another time it is moving along this direction. That means also it is vibrating, and by vibration direction is as like as the direction of wave. That means same way they are moving.
Yes, sir.
So the angle between the direction of wave and the vibration direction of the particle of the medium, parallel, you could say parallel also. Parallel means the angle
Understood.
between them 0. Am I right?
Yes, sir.
Okay, you can say both. And you've said well, you have answered correctly. That means you understand pretty well. Now it is clear the difference between transversal and longitudinal. I'm 100% sure. And your concept is so clear. If I describe anything, you may say perfectly. Anyway, actually, I have I've said about transversal and longitudinal. Moreover, you know the example of those waves. So good. Wave speed. Do you know the formula of wave speed? Do you know?
I think I studied it before, but I cannot remember. Something regarding lambda or something.
Okay, let me show you this.
V equals F lambda or something.
It's speed. Actually, mechanics is firmly correlated to others chapter. If you know mechanics, you can describe other part of fields such as light energy, sound energy, electric energy, magnetic energy. You can explain, or Einstein relativity and modern physics-based concept you can explain by mechanics. If you are not clear in mechanics, you can catch the essence of other chapter. Okay. Just now, I've asked you what's the speed of wave. If you know the mechanics, you can draw the concept of speed of sound. Okay. Just look, speed means v. Am I right?
Yes, sir.
Speed means v. And wave speed, what will be the speed? You know from the mechanics, speed equal s upon t. Am I right?
Yes, sir.
This is actually same here. Same here. No difference. No difference.
Oh.
But there is an equation which is like this. Remember, am I right?
Yes, sir.
This v equal lambda. Am I right?
Yes,
Just
sir.
like this equation is related to speed of wave, and you use this not only in sound but also you use this formula in light energy. Moreover, you use this formula in modern physics. Okay, you will use this modern physics. Modern physics means your syllabus actually I know until you if question pattern is different, descriptive. Okay, and descriptive and the answer is very short. And so sometimes you will face a practical based answer pattern. I know suffer that. But this equation is very important to your syllabus because frequently I saw some year gave this equation based mathematics or question. Anyway, so B equals lambda f. This is the speed of a wave. Here it means frequency, lambda means means
Wavelength?
wavelength. Now, do you have clear concept about wavelength and frequency? Is very
Yes, sir.
important. And I know so for that you first year question gave mathematics related to this formula. That is B equals lambda f. And lambda means wavelength and f means
It means the distance between one crest to the next crest or one trough to another trough.
no f.
Oh, F is frequency.
F is frequency means
Yeah, the amount of wave carried on 1 second.
good, excellent. You know pretty well.
Oh,
That means amount of what I have said, amount of
like waves transferred or something.
frequency. Actually, for understanding this, we have to draw analogy. Understand? Not from the wave graphics or picture. We can't understand this. I can understand from an example, or from an analogy. Suppose I may show you that example, and then you may understand how frequency is happened. Okay, suppose we don't know wave, but we know this ball. We know. Do you know this ball, this string, and we can hang like this way. We can hang, and if we pull to any side and release it, then it will vibrate. It will
Move.
Okay. Suppose I have drawn along this direction and then I release it. It will come again here and it will goes there. Again, it will come here and return the first pavilion. Then what will say?
An oscillation.
Oscillation. Okay. It is related to frequency. How many oscillations happened in 1 second?
1 second.
That is frequency. If you know this example, then you may understand frequency phenomena in wave. Wave is very complex part. That means there also we get vibration of particle. But those particles are invisible, so we can't get the essence. We can get the result. But we know the pendulum, simple pendulum, and by drawing this simple pendulum analogy and oscillation, we could understand F. Can you understand F here?
I think yes, sir.
Have you understood what I've said? Since we know the pendulum is actually a visible thing, we can see this, or we can understand the vibration of the ball of pendulum. And from that vibration, we can count how many complete vibration in 1 second. That is frequency.
Yeah.
That is
Frequency.
How many complete vibration? That means if you start from this point, it will go this equilibrium position, then it will go here, it will come back this point again, and finally it will go to its first point. This movement is called, this vibration is called complete oscillation.
Yes, sir. Complete oscillation.
And needed time, that means the number of complete oscillation in 1 second is called frequency.
Yes, sir.
I guess it is clear from this analogy or from this simple pendulum picture. But if you think about the wave, then you have to consider deeply how. I showed you in my previous lecture, in my previous section, I showed you, I drew the transverse wave, I drew the longitudinal waves, then I showed you the vibration of the particle of the medium. I showed you the vibration of particle. That particle, how many times get complete vibration in 1 second? That number is called frequency. Moreover, we count frequency in another way. Anyway, I guess you've understood this critical thing. Okay, this critical
Yes,
thing.
right. I understood.
But you said definition so well. You said the definition
Oh,
so
thank
smartly.
you.
But
Thank you, sir.
when you try to explain, then you obstruct it. Anyway, that doesn't mean that you are weak. It's very, very subtle point of view for understanding that you have to complete different side of physics, then you will get actually essence of that meaning. Anyway, now what I've said just now, I've said V equal lambda f. And what is lambda? What is lambda? Lambda is
the wavelength.
You said lambda is wavelength. Can you draw the wavelength of any wave? Or can you?
Yes, sir.
You can say the definition. Just now you have said that definition. The difference between crest or trough. You said.
Yeah.
Just now you said. That means you know this transverse. Am I right?
Yes, sir.
This is transversal, and it said this section is called wavelength. Am I right?
Yes, sir.
You said this wavelength, and just now have drawn a picture just now, a simple pendulum. Here, do you know simple pendulum? Have you heard or have you seen simple pendulum anywhere, any place? Or
yes, sir. I have used it once.
But you didn't see the wave of sound. You didn't see them. Those are invisible.
Yeah.
Those are invisible. Okay. And okay, fine. Wavelength and frequency, I said. Now, if you know this equation, you may solve some mathematics which you question or exam script give. Okay, then you
yes.
do those mathematics. Anyway, I have actually said the shorter meaning, and I've said reflection. Okay, fine. Do you know reflection and diffraction? Do you know? Since we have drawn the picture reflection, will the sound wave follow this reflection and diffraction?
Yes, sir, it can.
It can. Not only sound can, but also light can do this. Am I right?
Yes, sir.
Yeah. We've understood the speed. We've understood. The speed means, the definition. The speed definition was the speed definition from the mechanics chapter. What's the speed definition?
The definition of speed is the amount of distance traveled per unit time.
Nice, nice. That means here with speed means sound will move a distance,
Yeah.
right?
Yes, sir.
Per time. And do you know the light speed? Do you know the amount of light speed?
Yes, sir. It is around 300,000 kilometers per second.
3 into 10 to the power in short or in scientific number? 3 into 10 to the power?
Around 10 to the power 5.
8 meter
Oh,
per
sorry,
second.
8. Yeah, yes, right.
8 meter per second. And,
Oh, there are meters. I accidentally said kilometers.
no problem at all. Okay. Gradually it will be improved. Gradually it will be amended. Okay. That's not
Okay,
big
sir.
deal. After all, you are a student of class 9. You are not a student of class 10. Am I right? You are a
Yes, sir.
student of 9. So you are at primary level. So gradually, step by step, sooner or later, you will learn one by one. Okay. And do you know the speed of sound in air?
It is approximately 330 meters per second.
Yeah, you know this 300. And would you tell me what's the type of speed of sound and light? What's the name of the speed? It is, there is a different type of speed, different types of speed,
Yeah.
You've understood speed, but do you know the types of speed? How many types of speed?
I'm not sure, but like something like subsonic,
Okay.
supersonic.
No. That I am not saying. That
Oh.
is, I'm saying average speed, instantaneous speed. Have you heard this word?
Oh, yes, sir. I've heard average speed.
Yeah. Average speed, instantaneous speed, and could you tell?
I cannot remember. Sorry.
Okay, average speed, instantaneous speed, and constant speed.
Oh, yes. Constant speed, sir. Yeah. I remember. Yeah.
Constant amount on chance, amount on, and by the constant speed, what's the formula of displacement? Could you tell me?
In constant speed.
By the constant speed, what's the formula of displacement?
So it'll be the speed multiplied by time.
Yeah, S equal. Oh my gosh. S equal.
S equal d by t. Oh, sorry. S is not speed. Yeah, S is this
S equal dt. Am I right?
vt. Yes, sir.
What is this? What's the name of this speed?
This is velocity.
Okay, velocity. What's the name of this velocity?
Constant velocity.
Constant velocity. Have you understood?
Yes, sir.
Now it's a constant speed. Constant means, what do you mean by constant?
That it doesn't change over time.
It doesn't change. The amount of speed doesn't change. Amount.
Yeah.
Amount. If you consider this velocity, direction will not change, amount won't change. That is constant velocity. Now, I said another types of speed. Those are average speed. Do you know what is average speed? When will count average speed? Anyway, we are discussing waves, but we have gone into the mechanics. Actually, mechanics is firmly related to other chapter. If you know the mechanics, we may connect to higher level of physics. Okay. So we have to be clear in mechanics, and by learning all chapters day by day, then you improve your concept. And for examination, that is another concentration. By solving a lot of past paper, and by knowing the pattern of question, practicing again and again, then you may understand the format of exam question, and giving the answer will get glorious mark or glorious score. That is different matter. But if you want to know very deeply, you have to think, you have to feel, and you have to do practically. Anyway, theoretically, you do always for examination. Mathematically, you do always for examination. It's true. But if you want to understand or feel deeply, you have to read, think, right. Okay. Anyway, I've said very philosophical thing. Forget that. And we are discussing about the waves. Okay. And we have connected to the mechanics. Okay. Anyway, average speed. We are going to discuss about average speed. You can't explain this because it's a different case, and I have to explain you, or I have to describe you, or I have to say you by drawing picture or giving example. By giving example, I may make you understand the average speed. You understood the constant input. Average speed or average velocity means look. Where do you live?
I live in Sylhet division.
Okay, you live in Sylhet division. From Sylhet to Dhaka, you want to come. Sometime you speed. Sometimes the motion of your vehicle is more. Sometimes the motion of your vehicle is less. That means it will not move always in the same track, in the same format. Then you will count the average speed. Average speed. Sometimes your vehicle will stop, not move. That means for getting the average speed, you have to know the total distance. What I've said?
The total distance.
Total distance. And then you have to divide by total time. Don't think you are faster, you are slower, or you speed is way more, your speed is very less. You don't think that. You just think the total length or total distance or total distance you complete it. You have to count that and you have to divide the total time. Then you will get the average speed. Understand what I have said? Average
Yes,
speed,
sir.
you will get total distance. এবার শেষ
Yes, sir.
total
distance over total time.
Over total time. So you will count the average speed. Okay. Anyway, just you do mathematics. That is our necessary thing. And anyway, average is total. And just now I have said instantaneous speed. Okay. This is another point. I will not describe that. Okay. I've said about average speed and constant speed, or average velocity, constant velocity. Okay. If you understand my explanation, I'm sure you can give answer about average speed and constant speed. But could you tell me that what's the speed of wave? Is it average or constant?
Like, is there a constant speed for always?
Always constant. And light speed, is it average, instantaneous, or constant?
It should be constant.
It should be constant because the amount of speed, the magnitude of speed remains same. Am I right? And to
Yes, sir.
diffraction, I've said layout. Have to change the layout. Now you can see in different way. Am I right? And,
Yes, sir.
Okay, 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 nice. You, since you know this waves concept, that's why I'm sure you know about electricity. Actually, I have described a lot of things in every chapter. After all, you're a student of class 9, and after you student of class 9, that's why it's not necessary to describe all chapter. I'm saying about all chapter. Okay, I've been saying all chapters based concept. Devashish, can you catch it? Can you catch it? I've
Wait.
said about energy. I've said about waves. Now, if I discuss electricity, then
Yeah.
could you tell me anything about series and parallel circuit? Have you any? Do you have any concept or
Oh,
notion series and parallel circuits?
yes, sir. I know
Okay,
that
okay,
series and parallel circuits are kind of different because in series circuit, all the components are attached in a single loop where the current have to pass through all the elements in a single loop. And on the other hand, in the parallel circuit, the components can be attached in more than one loop. So in case one component gets damaged or destroyed, all the other components will be running. But in a series circuit, in case if one ingredient gets destroyed, the whole circuit gets open and electricity cannot flow. So these are just the basic differences of series and parallel circuits. Also, another important thing that in a series circuit, the voltage is shared, so the voltage is never equal in all sides, but the current is equal on all sides. On the other hand, in contrast, that in a parallel circuit, the voltage is equal in all portions, but the current is not equal in all portions.
excellent, good. That means
Uh,
these are the main concepts. Perhaps what you've said. That means you crystal clear concept about series and parallel connection. But whenever
mhm.
you face the creative question, then you have to do in different way. Moreover, I know you question pattern different. Okay, directly they are not giving series parallel connection. Do this nothing. They are not giving directly. Your question pattern is different. Could I show you question pattern? Huh?
Yes, sir.
Question. We are past paper question. You are IGCSE. Am I right?
Yes,
Not
sir.
not GCSE. Not you are IG. Anyway, and you are Edexcel. Am I right?
Yes, sir. Yes, sir.
Okay. You physics two parts. Am I right?
Yes, sir.
First part and second part. And uh, okay,
Yes, sir.
you clear concept series and parallel. Okay, fine. According to Ohm's law, you know the formula. You know very well. I
Yeah. I equals
let me
V
let
by R.
I equal V upon R.
V upon R.
You know this. Do you know
Yes, sir.
another formula? Do you know
Which one? Yeah, like V equals to IR.
this? I said, and you can say in different way, but I'm not saying that. I've said I equal V upon R. Like this way, there is another formula you could say, or you could try. Will I say? Same formula,
Uh,
but
Same kind of formula.
same formula, but a big difference. Another elements you have to join with this.
Ooh,
Get this?
anything related to power or something.
Let me write this blue color. Same I. Okay. I
Yeah.
equal here electromotive force and upon capital R plus small r. This formula. Do you know this?
Ooh,
Have you ever
I have
seen
never
this?
heard of it.
Yeah, I have seen. I have said this. I've said this now. Okay, same
Okay.
formula. This is and this is same, but you have to differentiate between B and E. Okay, next I'll show you this. Next class I'll show the difference between V and E. Or
Sure.
you may think this and you may find out what does V mean, what does E mean, and what are the difference between V and E. Moreover, you have to draw the picture for E and V. Hello, me. What do you mean by small r and capital R in the socket? Okay,
Yeah.
that's all today. And today I wanna finish my class. And you are very expert in physics. You have basic knowledge about physics. I'm very happy taking class with you. Okay, Deba,
Dibosh. Yes, sir.
Dibosh,
Yes, sir.
Dibosh Talukdar. Thanks a lot
Yes, sir.
joining with
Okay.
me. And are you satisfied?
Yes, sir. Everything was really wonderful. I liked the
Wonderful.
class.
Okay, okay. Well, go talk to your father and say him to call me.
Yeah.
Okay.
Okay, sir.
Okay. That's all today. Sweet dreams.
Okay, sir. Thank you. Goodbye.
Assalamu alaikum.
Yeah.